And then f of x equals x squared minus 4x plus 5, if they're all real numbers, express f of x in this form, that is, complete the square. So we have the minus 4, and square it, that gives us x squared minus 4x plus 4, so we have to minus 4, and then add 5, so it's going to be plus 1, and that's our answer. Just a little bit of background on completing the square, just in case you're not happy with it. I'm just going to go with x squared plus, I don't know, 6x for the moment. Then I could represent this as a triangle, x here, and x plus 6 here. Because if I split this up, this would equal x squared plus 6x. Now what I can do is divide this into 2, so this is now 3, and move it down here. So that bit is now gone. And the reason I do that is that I've basically turned it into a square. It's just there's a little bit missing. So this would now become x plus 3 squared. See, that's why I have the 6. But then I've got this bit that's not there. That's 9, so I have to minus 9 as a consequence. So you just got to learn overall to basically have whatever the coefficient of x is. In this case, it's negative. That's still okay. And then subtract whatever that is squared, because that's the missing bit in your square. It still works when it's a negative. And that leads to this answer here. We're told that the curve meets the y-axis at the point P and has a minimum turning point at Q. That's to write down the coordinates of P. So it meets the y-axis. That is when x is equal to 0. So I just need to substitute that in. I can substitute it into the original one. 0, 5. That 5 is the y-intercept. And then for Q, the turning point, well, I've got y equals, let's write it in completed square form now, like this. Okay, this term is never negative. It's always going to be greater or equal to 0. So the smallest it could be would be 0. And therefore the smallest that y could be is 1. And that is going to take place when the bracket is 0, i.e. when x is 2. And again, you just got to sort of learn over time that, yeah, you basically just take the opposite sign here for x, and then whatever this is for y, that will give you your minimum or your maximum depending on your quadratic. Great.